So we are on Monday, September 21st here, class 8. We're going to talk about other types of equations. So we've learned how to solve a couple of different kinds of equations so far. We did a little review of linear equations, and we solved rational equations that had fractions in them, and we've solved quadratic equations. So today we're going to talk about several other types of equations. Wednesday, next class, is your first in-class quiz. In-class, individual quiz. You can bring one 3x5 note card if you want. You can write whatever you want on it. To in-class quizzes, you can bring one little note card. And then next week is going to be your first test. And for tests, you can bring one page of paper with you. Write whatever you want on it, front and back. Okay. The back of your packet that we've been working through, the very end of the packet, has a study guide for the first test. Okay, so if you flip towards the back, the last several pages are a study guide. So now that we're getting close to the test, you might want to start working through that. All right, any questions about scheduling things? Yeah. Can you write on both sides? Sure. Yeah. This Friday, the 25th of September, is scheduled to be our review for test 1. So GCC is participating in this survey called the Sense Survey. I don't even really know what it is, but they picked a sample of all courses at GCC to administer this survey to, and you guys are one of them. Yay. So they're probably going to be here for like the first 30 minutes or so of this class. It's optional, you don't have to do it. And I think they schedule it for 45 minutes, but in my experience, it's like going to take somewhere between 15 and 30. And then the remainder of class will be review. So it's going to be an abbreviated review class unless everybody rushes through their survey, which, you know, it's up to you. So I just want you to be prepared for that. That class will be an abbreviated review class. All right, so I'm going to work through the preview exercises with you. These are some important things that are going to come up in helping us figure out how to solve other types of equations. All right, so if I want to factor x cubed minus 3x squared minus 4x, what's the first thing that jumps out at you? Factor out an x. Yeah, there's an x in every single term. So I could factor out an x. Sometimes I call that reverse distributing, right? It's like undo the distribution rule. So we pull out an x, and then think about if you were going to distribute that x to the 3 terms, x times what gives you x cubed, x squared, x times what gives you negative 3x squared, negative 3x, and x times what would give you negative 4x, negative 4. Good. And then x squared minus 3x minus 4, does that factor? Yeah. The coefficient on my x squared is a 1, so what I'm looking for are 2 numbers that multiply to negative 4 and add to negative 3. So I've still got the x from the previous step. And then this could factor to x minus 4, x plus 1. All right, so a little review of factoring. That's going to be helpful later. Now, if I want to multiply this binomial, right? I've got radical x plus 4 plus 1 squared, right? So squaring means take that thing and multiply it times itself, right? So I'm going to write out what this means. This is radical x plus 4 plus 1 times radical x plus 4 plus 1. And then I'm going to FOIL it, or distribute it, or use the lobster claw, whichever term you've learned, right? So if you do radical x plus 4 times radical x plus 4, what do you get? X plus 4, right? A radical something times a radical something is just the something. The radicals undo each other. So you get x plus 4. All right, so then go to your outer terms. Radical x plus 4 times 1 is radical x plus 4. Yeah, anything times 1 is itself. So this is plus radical x plus 4. And then for my inner terms, 1 times radical x plus 4 is again radical x plus 4. And then 1 times 1 is 1. So if I combine like terms, I have an x. Plus 4 and plus 1 is plus 5. And then radical x plus 4 plus radical x plus 4, 2 radical x plus 4. All right. So keep that in mind. When you want to square something, it means you have to multiply it times itself. So a really common mistake people make when they try to square that is just to square the first thing and then square the last thing, right? So it'd be very, very common to see somebody write radical x plus 4 plus 1 squared, and they would just say, oh, well, this squared is x plus 4, and 1 squared is 1, and write x plus 5, and say that's the answer, right? But when you square something, you have to actually multiply it times itself, do the FOIL all out. So this is not true, right? So be careful of that common mistake. Okay, if I substitute -8 into this equation that has rational exponents, let's see if the resulting equation is true or false. So this is 5 times -8 to the 2/3 plus 11 times -8 to the 1/3 plus 2. Does that actually equal 0? How do you raise -8 to the 2/3? What is that? What do you have to do? Without picking up your calculator. Oh, so the crying baby is if when you have a negative in the exponent, right? So the baby's happy, right? I don't have to move anything. Baby's happy because the exponent is positive. So when you have a fractional exponent like this, the number on the top is the power, the number on the bottom is the root, right? Because roots belong in the cellar, the bottom of the fraction. So I want to take the cube root of -8 and then square it. So what's the cube root of -8? -2, yeah, because -2 times -2 times -2 is -8. And then when you take -2 and square it, what do you get? 4, because -2 times -2 is 4. So this becomes 5 times 4. All right, -8 to the 1/3. So again, the root is in the cellar, the power is on top. So I want to take the cube root of -8, which was -2, and then raise it to the first power, which means you don't do anything. You get -2. You can do it either order. Yeah, I find taking the root is typically easier to do first, but either order will work. All right, and then plus 2. So that says 20 minus 22 plus 2. Does that equal 0? Yes. Okay, so yes, it's true. Okay. One more, talking about absolute value. If you take the absolute value of a number, do you get the same thing as if you take absolute value of the opposite of that number? Yes. So for example, the absolute value of 5, does that equal the absolute value of -5? Yes, right? They're both 5. If you started with a negative, the absolute of -7, does that equal the absolute value of 7? Yes. Okay, so this is always true. All right, so you might be able to guess from the preview exercises what kind of equations we're going to be learning how to solve today. Polynomial equations, radical equations, equations with rational exponents, and absolute value equations. All right, so the first one, polynomial equations. They can sometimes be solved by factoring and using the zero product principle. That's our only hope for polynomial equations as of today, right? You want to make one side 0 because then you can try to factor and use the zero product property. Do not divide both sides by an unknown, right? Do not divide both sides by x or x squared. Because what would happen if x were 0 and you divided by x? You'd be dividing by 0 and like the world would explode, right? That's not allowed. Okay. So we avoid the possibility of exploding the world by not dividing by x, right? So instead, you want to move everything to one side. So this is going to become x to the 4th plus x cubed minus 6x squared equals 0. So I just subtracted 6x squared from both sides. And then factor. Just do whatever you can to try to factor this side. There's an x squared in every term. I can factor out an x squared. So I get x squared plus x minus 6. Can that x squared factor any further? X minus 2, x plus 3. Yeah, so I've got x squared times x plus 2 times x minus 3 equals 0. All right, so the zero product property works just as well when you have 3 factors. If you multiply 3 things together and the answer is 0, one of those 3 things, at least one of those 3 things has to be 0. Yeah. Yes, it is. Thank you. I was just trying to see who was paying attention. Minus 2 plus 3. There we go. Good. Thank you. So if I multiply 3 factors together, multiplying 3 numbers together, and the answer is 0, at least one of those 3 things has to be 0. So I have either x squared is 0, or x minus 2 is 0, or x plus 3 has to be 0. One or all, right, could be 0, and the whole product would be 0. So x squared equals 0. The only solution to that is x equals 0. Oh, good thing we didn't divide by x, right? That would have been a disaster. Or here I add 2 to both sides and I get x equals 2. And here I subtract 3 from both sides and I get x equals negative 3. So I have 3 solutions. Any questions on the general technique? No. You could have fewer, you could have more. Yep. Yep. All right, radical equations. The key to solving a radical equation is to isolate the radical. Circle the radical, and you want to get it by itself before you do anything else. I want to get that square root x by itself. So what do I have to do first? Subtract x from both sides. Right, so those will go away, and I get the square root of x equals 12 minus x. Then, how do you undo having a square root? You square. Right, so now that the radical is isolated, then you square both sides. So radical x squared is just x, and 12 minus x squared is 12 minus x times 12 minus x. Oops. And FOIL it out, right? It's very tempting to just write 144 plus x squared, but when you FOIL it out, you see that's not what you get. We get x equals 144 minus 12x minus 12x, which is minus 24x, plus x squared. What kind of equation is that I've created now? Say it louder. Quadratic. How do you solve a quadratic equation? I know the weekend's a long time. Quadratic formula or factoring. Either way, what do you have to have first? One side has to be 0, so I'm going to subtract x from both sides. So I get 0 is x squared minus 25x plus 144. And then I could try to come up with numbers that make that factor. If none occur to you, like within a minute or two of how to factor that, I would just jump right to the quadratic formula. Yes. It's supposed to be 25 because I subtracted x from both sides, right? Negative 24 minus 1x is negative 25x. So nothing's jumping out at me. The only factors of 144 that I know off the top of my head are 12 and 12. They don't add to 25. There might be other factors that add to 25, but I'm just going to use the quadratic formula. So x is the opposite of b. Maybe I'll write this down just to remind people. Plus or minus the square root of b squared minus 4ac all over 2a. And in this case, b is negative 25. So the opposite of b is 25. Plus or minus the square root of negative 25 squared, 625, minus 4 times a is 1 times c is 144, all over 2 times 1. And I'm just going to have my calculator do all the hard work here. All right, so I have 25 plus square root 625 minus 4 times 1 times 144. And then divide that by 2, and I get 16. 16, or, right? So that was the plus part. That was the 25 plus square root of b squared minus 4ac all over 2a. And then I got to do the minus part. So I'm going to do second enter, and then just change that 25 plus to a 25 minus divided by 2, and I get 9. 16 or 9. Now, I should have in the first example checked my answers, right? You should always take your answers and plug them back in, make sure you did all the work right? So let's see what happens if I plug in 16 and 9 into the original equation. X plus radical x equals 12. So let's try 16. 16 plus radical 16, does that equal 12? No, what's radical 16? 4. So this says 16 plus 4 equals 12. That's not true. Okay, so either I made a mistake or 16 is definitely not a solution. Maybe I made a mistake, maybe not. Let's plug in 9. 9 plus radical 9, does that equal 12? Yeah, because radical 9 is 3. 9 plus 3 is in fact 12. Yep. So 9 is a solution, but 16 is not. So 16 is what we call extraneous. This happens a lot when you're dealing with radical equations, right? You'll end up with 2 solutions. One of them is not actually a solution. It's called extraneous, the root being extra, right? So you just throw that one away. So any questions here? Isolate the radical, then square both sides. And then you've turned it into something you already knew how to solve. Okay, equations with rational exponents. So the key to these is to isolate the term with the rational exponent. So you might want to circle it, right? Circle the term that has the fractional exponent. And then you have 2 methods. I'll show you both of them. But the first step is always to get that thing by itself. So what should I do first? Add 6 to both sides. So I'm going to have 3x to the 3/4 equals 6. I could isolate that x to the 3/4 even more. What would I do? Divide by 3. Right, so I have x to the 3/4 equals 2. So no matter which method you do, this is how you're going to start. You want to isolate the x to the fraction. Okay, so now I have two methods to choose from. So I'll put it over here. Method 1, method 2. You have two methods to choose from. You can always just use your favorite. You don't have to know how to do both of them. I'm going to show you them both right now. So the first one is to convert to, oops, look at that. It's already a rational equation. Convert to a radical equation and solve. So x to the 3/4 equals 2. Remember our rules about fractional exponents. The number on the top of the fraction is the power. The number on the bottom is the root. So this says the 4th root of x cubed, right? Instead of putting a 4 in the bottom of the fraction, we change that to a 4th root, and that equals 2. Haven't really done anything here except rewrite x to the 3/4 in a different way. You can do the 3 on the inside. The order doesn't matter which way you root and which way you root and do the power. The order doesn't matter. In fact, in this case, that's a good point because it's much easier, I think, if you put the power on the x. Okay. So then we think about what's being done to x, and we got to undo it. So in this second line I just wrote here, x is being cubed and then 4th rooted. How do you undo 4th rooting something? I just was saying that when you have a fractional exponent, the number on top is a power and the number on the bottom is a root, and it does not matter which order you write it in. You could write the 4th root of x cubed or x cubed 4th rooted. They are the same thing. Correct. Right. You can't switch where the 3 and the 4 are. Yeah. But you can raise to a power and then root, or you can root and then raise to a power. Doesn't matter. Raise to the 4th power. Yeah, to undo 4th rooting, raise to the 4th power. So I'm going to raise both sides to the 4th power here. So my 4th root and my 4th power cancel, and I'm just left with x cubed. And 2 to the 4th is 16. So x cubed is 16. How do you undo cubing? Cube root it. Cube root. Cube root. Cube root of x cubed is x. Cube root of 16. Yeah. You can just leave it as the cube root of 16, or you could simplify it. You could just call it the cube root of 16, which you can simplify. Are there any perfect cube factors of 16? 4 is a perfect square. 8 is a perfect cube, right? 2 cubed is 8. So I could rewrite this as the cube root of 8 times 2. Cube root of 8 is 2. And then you still have a 2 under the cube root. 2 cube roots of 2. You can also just circle cube root of 16. That's fine with me too. All right, so that's method 1, which is convert it from a fractional exponent to a radical, right? To change the bottom to the root. All right, the other method, a lot of people like this better after they've seen the first one. Okay, if you have x to the 3/4 equals 2, I'm going to raise both sides to a power. It's a little bit cleaner. X to the 3/4 equals 2. So I'm going to raise both sides to a power, some unknown power. which is totally legit. I can totally have the power to do that as long as I do the same thing to both sides. So I want to choose the exponent that I raise x to the 3/4 to very carefully, so that when I raise x to the 3/4 to this new power, my answer is just going to be x to the first. Okay. And what's the rule when you raise a power to a power? What do you do to them? You multiply them. Yeah. So what should I multiply 3/4 by to make a 1? 4/3. So I'm going to raise both sides to the 4/3 power. Okay. So when you raise a power to a power, you multiply the exponents. So I chose my exponent to be the thing I multiply 3/4 by to make 1, which is the reciprocal. Okay, 3/4 times 4/3 is 1. So this becomes x to the first. And 2 to the 4/3, remember 4 is the power, 3 is the root. So you do 2 to the 4th and then cube root it. So 2 to the 4th is 16. So this is the cube root of 16. What was that? So much simpler, yeah. No, you don't have to write the 1. I just did it so that to make the point of what we were doing. Yeah. All right, so you can pick your favorite method here. Whatever you like best. It's fine. For both of them, I don't make a big deal about simplifying radicals. Some teachers do. It really kind of depends on why you're solving this equation. Yeah. All right, let's look at one more kind of equation, an absolute value equation. The key to solving an equation that has absolute value bars is to isolate the absolute value so that your equation looks like the absolute value of some stuff equals a number, and then convert to two equations, right? So if the absolute value of something is 11, then that something that's in the absolute values could be 11, right? It could be that 2x plus 1 is 11, or it could be that 2x plus 1, whatever is in the absolute value bars, it could also be negative 11, because then when you take its absolute value, you would get 11. Does that make sense? So if you have the absolute value of some stuff equals a number, you take your stuff and set it equal to the number, and then you take the stuff and you set it equal to the negative of the number. And then you have to solve two equations, so you'll get two solutions. So this one you get x equals 5, and this one you get x equals negative 6. I didn't show the work. I think you can handle that on your own. But then we'll do a quick check just to make sure that these are actually both solutions. So I've got the absolute value of 2 times 5 plus 1. Does that actually equal 11? Yeah, because 2 times 5 is 10, plus 1 is 11, and the absolute value of 11 is, in fact, 11. Okay, let's look at the negative 6. Absolute value of 2 times negative 6 plus 1. Does that equal 11? Well, 2 times negative 6 is negative 12, plus 1 is negative 11. Does the absolute value of negative 11 equal 11? Yes. So they are both solutions. Oh, sorry, I thought I was done. There's a little bit more. Okay, last thing is linear inequalities. So the key to solving a linear inequality is to treat it just exactly like a linear equation, but instead of an equal sign, you have an alligator, either a less than or a greater than sign. And you have to remember that if you multiply or divide both sides by a negative in your process of solving, then the alligator turns around, right? So for example, if I want to solve negative 4x is less than 8, to get the x by itself, I would divide both sides by negative 4, right? So my negative 4's cancel. On the left, I have an x, and on the right, I have a negative 2. But because I divided by a negative, the sign flips. The alligator was going this way, right? Now it's going to go this way. So x is greater than negative 2. So there's my answer, but I'm supposed to express it using set builder on a number line and with interval notation. So this is just a little review from a few classes ago. So set builder that's the curly brackets, the set of all x's such that x is greater than negative 2. Number line, we find negative 2, and it's all values bigger than negative 2, which means left or right. Right, to the right are numbers that are bigger than negative 2. Do I include the negative 2? No, so I put this round parenthesis there and shade everything to the right. And then interval notation. If I start from the number line, I would say negative 2 with a parenthesis, because I don't include it, is my smallest number in the set, and I go up to infinity, and you never include infinity in an interval. All right, now a compound inequality is to treat it like an equation that has 3 sides. Okay, so whatever you do to one of the 3 pieces, you have to do to all 3 pieces. Your goal is to isolate the x in the middle of the sandwich. Okay, so if I want to isolate the x in the middle here, what do I have to do? Add 4. And I'm going to add 4 to all 3 sides. So negative 6 plus 4 is negative 2. X minus 4 plus 4 is x. 1 plus 4 is 5. Do I have to turn my alligators around? No, because I didn't multiply or divide by a negative number. So these stay like that. And you could express your answer in any of the 3 ways: set builder, interval, or a number line. It would be the set of all x's such that x is sandwiched between negative 2 and 5. Yep. That's set builder. Interval, we'd go negative 2, comma 5. Don't include the negative 2 because it's strictly bigger than, but include the 5 because it's or equal to. All right, so that's kind of a lot. I showed you 4 new kinds of equations to solve, plus inequalities. So now you have a bunch of problems to practice with. And there was a question, yes? Because this was strictly less than, not equal to, so that corresponds to a parenthesis. This one had the or equal to, which means include the 5, so that gets a square bracket. Yeah, Lex? Oh, yeah, I was just, when I shaded the solution, that's when I put the arrow in. Yeah, I guess technically there's arrows for the number line also. Yeah. Doesn't really matter, yeah. Good questions, okay. All right, so why don't you try some? If you have questions, you can always refer to the notes or call me over.